So in the first video in this series, we actually talked about exploring Mars, what's so important about Mars and why you want to go there. In this second video, I'm going to be talking about one of the 3 Mars missions that's launching in July, and that's the NASA Mars 2020 mission. And one key part of that mission is the Perseverance Rover. And so we're going to talk a little bit about the mission and specifically about that rover. So this chart provides a brief overview of the Mars 2020 mission. As I mentioned in the first video, one key aspect of this mission is to land a rover called Perseverance on the surface. And Perseverance will drive around the surface, really looking for signs of ancient life. And now I'm not talking about Martians here, but more sort of very basic life like bacteria and so on. It will also collect and analyze rock samples while it's on the Mars surface, and it will keep some samples behind for a subsequent mission to retrieve and return to Earth for further analysis. As I've mentioned last time, the plan at the moment is to launch the mission on July the 30th. If for some reason as a technical issue arises, NASA has about a 2-week window in which to launch it. If it doesn't launch in that 2-week window, then NASA will have to wait another 2 years before it could launch this mission until Mars becomes closer to Earth again. The landing site is Jezero crater, which I'll talk about in a second, and it takes about 6 months to get to Mars, and so the landing of the rover on Mars is scheduled for February the 18th, and that mission is due to last for about 2 Earth years. One interesting additional feature of this mission is there is a helicopter on board the spacecraft that will be attached to the bottom of the rover, and the idea is to see really if it's possible to fly on Mars. And in the third video in this series, I'll be talking about the Mars helicopter in a little bit more detail. This is an image of Jezero crater taken from a Mars orbiter that shows where the Mars 2020 rover will be landed. It's an exciting area because scientists can tell from this picture really that water used to flow through this crater, and so it's an ideal place to actually do some research. This illustration shows some of the main components of the Perseverance rover. It's very similar to the Curiosity rover that's currently driving around Mars and has been there for a number of years. The cameras on board Perseverance are a little bit more sophisticated. It also contains a laser that can be used to vaporize rocks, and there are facilities on the rover to actually analyze the results of that vaporization to actually look at what the rocks are made of. As I mentioned before, the Mars helicopter is attached to the bottom of the rover. And then lastly, it has another capability on the rover that it can take the carbon dioxide out of the Martian atmosphere and convert it into oxygen. That's going to become very important in the future because currently astronauts can't breathe on Mars, but if you can convert the carbon dioxide of the atmosphere into oxygen, that will be of tremendous benefit. As I was preparing this video, I remembered that last year NASA was providing the capability for people to submit their names and have their names encoded on a chip on the spacecraft that's going to Mars. And so I did that. And in fact, as you can see from this chart, I got 300 million frequent flyer miles for doing that. In fact, close to 11 million people submitted their names. So I find it quite exciting that my name's going to be on a chip on a spacecraft that's going to Mars. One fun thing I did last year was visit JPL, the Jet Propulsion Laboratory in Pasadena, California. They do tours for the public, and I got a ticket online to do that. You can't do that at the moment because of the virus situation, but in the future, when we're past this problem, you too could get a ticket to do this. And if you have the opportunity, it's a fun place to visit. When I was there, they were building the Mars 2020 rover, Perseverance. And I find it really exciting to actually see that rover being built. And these are two photographs I took while I was down there. And it's fun to see something built that's going to be launched in a few weeks' time to Mars. The other thing you can see at JPL are models of various projects that JPL's built over the years. In fact, this is a full-scale model of the Mars Curiosity rover that I mentioned earlier. The Curiosity rover has been driving around on Mars for a number of years, taking photographs and analyzing the surface. This screen capture here is taken from the NASA website. You can actually go to the NASA JPL website and look at the mission status of all of its different projects, and you can see what the Mars Curiosity rover is up to at any point in time. So the question is, how did they manage to land Curiosity on the surface of Mars? And I'm going to show you a 1-minute video from JPL that shows you how they did that. And it's important to point out that the method used to land the Perseverance rover will be very similar to the technique used to land the Curiosity rover.
How do you land on Mars? Very carefully. Your spacecraft hurtles toward the planet at thousands of miles per hour, so you'll have to hit the brakes in a hurry. First, your capsule needs a heat shield. It protects the spacecraft inside from the heat and friction of entry into the atmosphere. Friction slows you down over 90%, but not enough to land safely. Use a parachute to slow down even more. Still, falling at over 100 miles per hour, you need the right system to land safely. Here are some options. With a small to mid-size rover, use a cushion of airbags along with retro rockets. Impact at 30 miles an hour and bounce to a stop. With a large lander, use retro rockets and landing legs to touch down going about 6 miles an hour. Or with a large heavy rover, use a big jetpack to slow down to under 2 miles an hour. Then gently lower it on cables to land on its wheels. Any way you do it, you'll need skill and hard work. There's nothing easy about landing on Mars.
Curiosity was a pretty large rover, and so it used the third option for landing shown in that video. In fact, Perseverance will use the same technique. One change with Perseverance, though, is shown on this slide here. What Perseverance does, it will photograph the surface as it descends. If it decides that the surface it's about to land on isn't really that suitable, it can actually divert to another landing spot. So now the rover has been landed on the surface of Mars, either Curiosity or Perseverance. The question is, how do you drive a rover on Mars? There's no astronaut to drive it. It has to be driven remotely. So how does NASA do that? So again, I'm going to show you another 1-minute video that explains how NASA JPL designed the Perseverance rover to be able to drive around on the Mars surface.
How do rovers drive on Mars? First of all, there's no joystick for driving a Mars rover. Before a rover hits the road, engineers send computer commands overnight, telling it where to go the next day. Depending on how tricky the terrain is, rover drivers have two options. They can send a string of specific commands like drive forward 5 meters, then turn right 90 degrees. The rover turns its wheels enough times to add up to 5 meters, and then turns in place. Or if it looks safe, they can let the rover think on its own. They write commands like, see that rock over there? Find your way there safely. Then, using 2 cameras like human eyes, the rover gets a 3D view of hazards such as large rocks and steep slopes. After mapping the danger zones, it plots the safest route to avoid them. Either way, did the rover complete its drive as planned? Engineers double-check when the rover sends back a postcard of its new spot on Mars.
So that's a quick overview of the Perseverance rover. Underneath the Perseverance rover there will be a helicopter called the Ingenuity helicopter. And in the third video in this series, I'm going to be talking about the helicopter and how it works. And also I'll be talking about how you can build your own helicopter at home. So thank you for watching and listening today. Hope you found it useful. I'd also like to thank NASA for providing me with the material that I presented to you today, and I look forward to talking to you again in the future. Thank you.